Hello, welcome to chemistry class. Today the topic is green chemistry. This topic is relevant to your module 2 syllabus. And what is the green chemistry? Green chemistry is the design of chemical products and processes that reduce or eliminate the use or generation of hazardous substances. Green chemistry applies across the life cycle of a chemical product, including its design, manufacture, use, and ultimate disposal. As we know that today the environment is continuously is going on polluting, and that's why we have to do search for the environment. There are some such terms like green chemistry, which is also called sustainable chemistry, is an area of chemistry and chemical engineering focused on the designing of products and processes that minimize or eliminate the use and generation of hazardous substances. And first of all, I am telling you what is the benefits of green chemistry. Why we are study the green chemistry? It is very benefit for human health. It clean air, less release of hazardous chemical to the air, leading to the less damage of the lungs, cleaner water, less release of hazardous chemical waste to water, leading to the cleaner drinking and recreational water. So there are so many benefits of green chemistry. There are so many applications also in pharmaceutical chemistry and day-to-day life. There are so many applications. This is the also known as sustainable chemistry. And how is chemistry useful in the everyday life? Chemistry is important in everyday life. Okay, so we have to save our environment to minimize the hazardous substances which are continuously going in the atmosphere. So that's why we are taking this topic, which is green chemistry. While environment chemistry focus on the effects of polluting chemicals on the nature, okay, engineering chemistry, environmental chemistry focus on the effects of polluting. What is the effect of polluting? Like what is the effect of smoke? What is the effect of CO2? What is the effect of NO3, H2SO4? The environment chemistry focus on the effect of polluting chemicals on the nature. But green chemistry, what is the green chemistry? Green chemistry focus on the environment impact of chemistry. Okay, green chemistry focus on the environment impact of chemistry, including reducing consumption of non-renewable resources and technological approaches for preventing pollution. Okay, what is a sustainable chemistry? What is a sustainable chemistry? If we are using air, water, land, at one time comes when all the air, water, and consumption of air, water, land is going to very high, going to increasing. So we have to save air, water, land. Okay, that's why because of our offsprings. This is the green chemistry. Which what is a green chemistry? Design of chemical products and processes that reduce or eliminate the use or generation of substances hazardous to humans, animals, plants, and the environment. So this is the green chemistry. The principle covers such concept, and who given the term green chemistry? In 1998, Paul Anestus given the term green chemistry and published a set of principles to guide the practice of green chemistry. And what is the principles cover such concepts? There are 12 principles, and these principles covering such concepts like the design of processes to maximize the amount of raw material that ends up in the product, the use of renewable material feedstocks and energy resources, the use of safe environmentally benign substances including solvents whenever possible, the design of energy efficiency processes, avoiding the production of waste, which is viewed as the ideal form of waste management. Okay students, so these are the principles cover such concepts for the 12 principles of green chemistry. There are 12 principles of green chemistry, and the one is the prevention. The first is the prevention. What is the prevention? Preventing waste is better than treating or cleaning up waste after it is created. Preventing waste, it is very necessary to prevent the waste. In spite of when the waste is created, then you have to treat or clean. Okay, so this is the prevention. What is the prevention? Prevention is waste is better than treating or cleaning up the waste after it is created. The next is the atom economy, which is very important point. Atom economy. What is the atom economy? Synthetic methods should try to maximize the incorporation of all material used in the process into the final product. This means that less waste will be generated as a result. So what is the atom economy? I mean to say, if we are taking reactant A plus if we are taking reactant A should be completely converted into product B. There is no formation of byproduct. If the byproduct is formed, you have to clean it, you have to treat or clean it. Okay, so that's why what is the meaning of atom economy? Atom economy, the some the whole reactant is completely converted into the final product. There should be not any type of byproduct. Okay, the third one is the less hazardous chemical synthesis. There are so many syntheses are carried out in the laboratory for the synthesis of heterocyclic compounds, for the synthesis of many medicines. You know, all the drugs, medicines are used, are synthesized in the lab. So we have to avoid using or generating the substances which are very toxic to human and the environment. Okay, it is very necessary for us. Less hazardous chemical synthesis should be carried out in the laboratory. Next one is the designing safer chemicals. Chemical products should be designed to achieve their desired function while being as non-toxic as possible. Designing safer chemicals. We should make chemicals which are very safe, which are very safe to us. So it should not be it should not be very toxic to us. So we have to design safer chemicals. Safer solvents and auxiliary substances should be avoided whenever possible, and as non-hazardous as possible when they must be used. We have to use safer solvent. As we know that in the laboratory, in the conventional synthesis, there are so many solvents are used, like pyridine, like THF. There are so many solvents are used which are very toxic to us, which are very hazardous for human health. So we have to avoid these solvents. We have to use safe solvents like a green solvent, which is water we are using. The water, we are also, some reactions are today are carried out like microwave assisted reactions, in which the solvent is taking very mild solvent like water, like solid CO2, like many green solvents are used for the synthesis of compounds, synthesis of organic chemistry, or synthesis of organic reactions. Next one is the designing for the energy efficiency. Energy requirement should be minimized and process should be conducted at ambient temperature and pressure whenever possible. Okay, so it is very clear. Processes should be conducted at ambient temperature and pressure. It is not compulsory to do the reaction at very high temperature, at very high pressure. It should be ambient temperature and pressure whenever possible. The next one is the use of renewable feedstocks whenever it is practical to do so. Renewable feedstocks or raw materials are preferable to non-renewable ones. This is the very important point. Reduce derivatives. Unnecessary generation of derivatives such as the use of protecting groups should be minimized or avoided if possible. Such steps require additional reagents and may generate additional waste. As we know that when many reactions are carried out, we have to protect the reactant. So there are protecting groups are used, like from one side, like BOC. There are so many groups which are used for. So we have to avoid the derivatives formation. If these derivatives, we have to reduce the derivatives. Okay, so these are derivatives are formed just because of we are adding the some reagents, additional reagents we are using. That's why there are so many derivatives are formed. So we have to take precaution that reduce the derivatives. The next one is very important, catalysis. Catalytic reagents that can be used in small quantities to repeat a reaction are superior to stoichiometric reagents that it can be used in small quantities to repeat a reactions. Okay, this is the catalysis. Design for degradation. Chemical products should be designed so that they do not pollute the environment. When their function is complete, they should break down into non-harmful products. So what is the design of degradation? The reactants, the reactant or product should be designed like this. It doesn't pollute the environment. When their function is complete, they should break down into non-harmful products. The next one is the real-time analysis for pollution prevention. Analytical methodologies need to be further developed to permit real-time in-process monitoring and control before hazardous substances form. Inherently safer chemistry for accident prevention. Whenever possible, the substances in a process and the forms of those substances should be chosen to minimize the risks such as explosion, fires, and accidental release. So we have to take care for these reactions in which the explosion, fires, and accident is going on. Okay, this is the 12 principles of green chemistry, and these 12 principles of green chemistry is very important for for the laboratory, for where the reactions are carried down in microwave. So the microwave chemistry and green chemistries are complementary to each other. Okay, they are the complementary pedagogies, we can say. This is the 12 principles of green chemistry. Here this is the very short graph, which is a this is the waste prevention, less hazardous chemical synthesis, safer solvent, use of renewable feedstocks, catalysis, real-time analysis, atomic economy, designing safer chemical, design for energy efficiency, reduce derivatives, design for degradation, safer chemistry for accidental prevention. Okay, so you have to learn sequentially. It is very important for exams. The next one is the green solvents. So solvents are consumed in large quantities in many chemical synthesis as well as for cleaning and degreasing. Traditional solvents are often toxic or are chlorinated. Green solvents, on the other hand, are generally derived from the renewable resources and biodegradable to innocuous. So often a naturally occurring product. So we have to take natural resources, we have to use natural resources for the green chemistry, the solvents which we are using. So the idea of green solvents express the goal to minimize the environmental impact resulting from the use of solvents in chemical production. So these are the green, there we have to use green solvents. Green solvents are environmentally very friendly solvents or biosolvents which are derived from the processing of agricultural crops. The use of petrochemical solvents is the key to the majority of chemical processes, but not without severe implication on the environment. What are the green solvent? Give some example, like we can use carbon dioxide, most commonly used supercritical fluid, supercritical CO2 and water are considered green solvent in many industrial processes. So we can use water. In 2005, review identified three key developments in green chemistry in the field of organic synthesis. Use of supercritical carbon dioxide as a green solvent, hydrogen peroxide for clean oxidation, use of hydrogen in asymmetric synthesis. Some further examples of applied green chemistry are supercritical water oxidation on water reaction and dry media reactions. Okay, so these are the solvents which we can use in the green chemistry. The very important term, which is the atom economy. The atom, what is the atom economy? Atom economy is the conversion efficiency of a chemical process in terms of all atoms involved and the desired product produced. The simplest one was introduced by Trost in 1991 and called the simply atom economy. What is the atom economy? It is the ratio between the mass of desired product to the total mass of the product, expressed as a percentage. The concept of atom economy and the idea of making it a primary criteria for improvement in chemistry is a part of green chemistry. This movement was impulsed by the Anastas from the early 1990s. Atom economy is an important concept of green chemistry philosophy and one of the most widely used methods for the measuring the greenness of a process of synthesis. What is a calculation? We can calculate, suppose this is a reaction, methane react with the oxygen and the water and CO2 is formed. How we can calculate? This is the molecular formula of CH4. Carbon is 12 plus 4 16, 2O2 2 plus 32 64. CO2 is the gas. There is no, this is a no molecular formula, though no there is no molecular formula, it is gas. 2H2O 2 into 18 36. Total mass of reactant, we will add it 16 plus 64 and total mass of desired, which is the 36. What is the atom economy? What is the atom economy? Total mass of desired product upon total mass of reactant atoms. Okay students, total mass of the desired product upon total mass of reactant atoms. This is the into 100. This is the atom economy which we can calculate. Okay, and the next one, creating reactions utilizing atom economy. Suppose that in chemical reaction A plus B plus C plus D that two products are necessarily generated through product C may have been the desired one, in which the C one is the desired. That being the case, D is considered as a byproduct, as it is a significant goal of green chemistry to maximize the efficiency of the reactants. And what is the meaning of this sentence? What is the significance goal of green chemistry? Maximize the efficiency of reactants but minimize the production of the waste. D must either be found to have use, be eliminated, or be as insignificant and innocuous as possible. With the new equations of the form A plus B gives C the first step in making chemical manufacturing more efficient is the use of reactions that resembles simple addition reactions with the only additions being catalytic materials. So it is very clear, if they are addition reactions, if they are isomerization reaction, the yield of the product, the efficiency will be 100%. It is very clear. This is a graph of atom economy. If there is no reaction, if there is substitution reaction, elimination reaction, this is the atom economy. This is the chiral resolution. This is the atom economy. Here the graph is narrow. Stoichiometric reagents, if we are using catalytic reaction, it is increasing. But if we are using, if we are reactions are carried out like addition or rearrangement or isomerization reaction, atom economy, atom economy is 100% atom economy. So very important, this is the atom economy which is increasing when we are treating the reactant like addition reaction or rearrangement reaction or isomerization reaction. So students, this is all about green chemistry which is in your syllabus. It is very important topic. What is the green chemistry? Green chemistry to minimize the polluting substances or hazardous substances which harms to humans, animals and plants. To minimize the hazardous substances, to minimize the hazardous substances, we are using the term green chemistry. Okay students, thank you.